back to the NFL example from earlier, but this time we're going to use a normal approximation instead of a simulation. So notice that when you do a theory-based test for one proportion, the name for that test is a one proportion z-test. Okay, so the first thing that we need to do if we ever want to do a normal approximation is that we have to check our validity conditions. So we have to find the number of expected successes and failures. So the expected successes, that's going to be the sample size times the value from the null hypothesis. So in this example, our sample size is 428, and our null hypothesis was that the rule was fair, that whether you won the coin flip or not, you had an equal chance of winning the game. So the value in the null hypothesis was 0.5, and that comes out to be 214, so definitely bigger than 10 here. And for the expected failures, we're doing 1 minus the value from the null hypothesis. So when it's equal to 0.5, this of course gives us the same thing, 214, and it's still bigger than 10. So because both of these conditions are met, that's telling us that the sample size is large enough to use the normal approximation. So this is a guideline to tell us how large our sample size needs to be before it's reasonable to use theory. So we're not going to do a simulation here, so we have to use the formula to find the standard error. So to do that, I'm going to plug in something for pi. I'm assuming that the null hypothesis is true through this whole process, so I'm going to be plugging in 0.5 here. And then obviously 1 minus 0.5 is the same. Dividing it by the sample size, and that gives me a standard error of 0.024. And if you remember, that's actually the same standard error that we saw when we were using the standard deviation of the simulated distribution to find standard error. To calculate our z-statistic, we take the statistic minus the null value and divide by the standard error. This is obviously the exact same calculation as what we did earlier because this is all the same values. We just got it from a formula instead of getting it from a simulation. So again, this comes out to 2.529. Okay, so what about the p-value? So we're actually going to use a different applet here that just uses the normal distribution to find the p-value. So go back to that main ISI applet page, but this time pick theory-based inference. So it's already set for one proportion, that's what we want. The sample size is 428. The count here, we're going to put in our number of successes, which is 240. And that'll give us the sample proportion, shows us a little bar graph here. And then I'm going to click where it says test of significance. And notice all it's giving me is a normal curve. It didn't do a simulation here. I'm going to change it. Instead of less than, I want it to be greater than. And then I have to click calculate to make it find the p-value. So you can see it's giving me my z-statistic here, a little different due to rounding, I think. And then the way it's finding the p-value is by shading the area under the curve there. So that 0.0060, that's shading the area under the curve. So we can find our sample value here. And this actually has two different scales on it. It has p hat and z. So we can find p hat is 0.5607, or the z value to 0.529. And we're going to shade the area under the curve. Find the p-value by shading the area under the curve. And we do have to use some kind of applet or calculator for this. There's not like a tidy formula for it. But when we do that, we get our p-value, and it came out to be 0.006. So you may be wondering how that compares to a simulation-based approach. Let's go back to our one proportion applet. So our null hypothesis was 0.5, our sample size was 428, and our number of successes was 240. Oh, I want it to be in terms of the proportion, I guess. So you can see pretty close here, 0.007, very close to what we got with theory. And when this box for the normal approximation is checked, it'll actually show you the theory-based p-value here too, 0.0060. So it should work out this way. When your validity conditions are met, you should get a very similar p-value, no matter whether you use simulation or theory. So whichever of those p-values you use, Either way, this is giving us very strong evidence against the null and for the alternative. So strong evidence that winning the coin toss is an advantage. So this is consistent with the conclusion that we drew earlier when we were looking at the z-statistic.